It's always nice to watch a flat earther struggle with simple concepts, like in this case the inverse square law. In a somewhat heated debate by Gean Techman with Fight the Flat Earth and PhD Tony, Techman claimed that the moon landings were fake because the inverse square law would imply that the luminosity on the moon's surface was more than that of the sun. Both Greg of FTFE and PhD Tony challenged Techman to show the math for that statement. Look what that led to.
The inverse square law, we have, and simply as I'm showing here, as it's explained, right? It's squared over distance. I have another, which I like to just say, let's use it at its maximum, which would be the point 0.1, right?
Yep.
Okay. So as we traveled to the moon, 253,000 miles, we cut that in half. The luminosity of the moon should double at that point, correct?
Correct.
Okay. So if we travel half of that distance,
Yep.
it should double again.
Are you going to go through Zeno's paradox for us?
If it's something that I'm not familiar with, let me know. But this is just my speculation of the moon landing, that by any measure, based on using the inverse square law, the luminosity of the moon should have been more intense than the sun for those men on that orb, which is going to be intensely more intense than the light from the sun on Earth. It's going to be brighter than what we get from the sun on Earth. Yes, it is. Do the math. Don't believe me. Do the math. Don't believe me. Do the math.
Look, you're the one making the claim.
Yes, and it is. I went through this a couple different times. I wish I had my notes with me about going over the inverse square law that I wrote to myself. I ended up throwing them away because it's just do it right now, Tony. Let's go through it right now. You're so smart, physicist. Let's go through it right now. How bright is the sun? How bright should the sun be? How bright should the moon be on the surface?
2,000 kilometers above the moon's surface, you would have a maximum intensity of 5,000 lux. Now, we can make lights that are much brighter than that.
I believe it could possibly even be brighter than that, Tony. And that's why I'm saying maybe we could do this math together
okay, all right, let's do the math together.
Because I think it's brighter than that. I think it's an intensity that's even brighter than the sun on Earth's surface.
Okay, all right.
Of course, Techman has all kinds of excuses. He did the math, but he doesn't have the notes with him. He shows a diagram which shows the principle of the inverse square law, but not the calculations. He starts off with repeatedly cutting the distance in half and quadrupling the intensity of the light, and ends with the intensity of the moon would be greater than that of the sun. PhD Tony does the math for him, and Techman just says that he thinks it's wrong. Let's walk slowly through the calculations. The inverse square law gives a ratio between the intensities at different distances and the inverse square of those distances, or I2 over I1 equals R1 squared over R2 squared, where I is the intensity and R is the distance. First, let's address Techman's statement that this formula in no way leads to the conclusion that the intensity of the light never decreases to zero.
The inverse square law says that light will never reduce to nothing, to zero. It will always have a certain amount, right? It will never become nothing. Do you understand that?
The inverse square law does not state that, Craig. You've added a lot of muscle to that. You added a lot of muscle to that.
Absolutely does.
If I1 is the intensity at the light source, in order for the intensity at the observer to be zero, the division R1 squared divided by R2 squared should be zero. This only can be the case with R1 being zero. R1 is the distance to the center of the light source. The distance from the surface of a sphere to the center of that sphere always is greater than zero, so the intensity at the observer always will be greater than zero. But let's perform the calculations Techman says he has done but he obviously hasn't. The intensity of moonlight on the Earth is around 0.1 lux. The distance from the surface of the Earth to the center of the Moon is 378,000 kilometers. We can therefore calculate the intensity of the moonlight at its surface, that is, at a distance of 1737 kilometers from its center, and it comes out to be 4736 lux. This is equivalent somewhere in between a dark cloudy day and indirect daylight, so nothing special. Now, what about Techman's statement that light can't travel that far? In fact, that in the heliocentric model you wouldn't be able to see stars because they are too far away. All of this due to the inverse square law.
And the inverse square law proves that stars are not even a light hour away, let alone
No, it
light
doesn't.
years, trillions of light years.
look up-
Physically
if you
impossible.
look up-
Light
you
can't
are-
travel that
you
far.
are-
Light
you
cannot
are-
travel that far.
Stop, one sec,
They were
please,
floating on a
please, one
ball.
sec. Right,
Not
both of you,
even
one sec.
What is your evidence?
guys,
what is your
guys.
evidence that light can't travel that far?
Yeah,
The
this is
inverse
what this
square
is
law is
what
my
right.
evidence.
Right,
The inverse square law
please
is
give me
my
the maths,
evidence.
The visibility of an object is not dependent on its luminosity. It's dependent on whether or not your retina, or the sensor of your camera, is able to capture any photons coming from the source. However small the luminosity may be, if there is any luminosity at all, there must be coming photons towards you, and therefore your retina, or the sensor of your camera, will always receive photons. And the human eye can detect a light flash with as little as 30 photons, as studies have shown.
Intensity is the number of photons per square meter per unit time. So, if something is low intensity, all I need to do is wait.
So Techman is wrong on every possible statement he made about this subject. But this could be expected. After all, though he presents himself as a truth seeker, at the end of the day, he's just another flat earther.